Okay, so number 10 is asking us to find, oh, this one's big, this one's huge. And what I'm about to tell you, this is a really good video, okay? So because the video, the Ed puzzle, my mistake again, was silent, you need to hear this to see the easy way to do this, okay? Now, hold on to your hats because this is a process. This is a big problem right now, okay? We are trying to find not the derivative of f of x. That's not what we're trying to find. What we're trying to find is first find the inverse function and then derive that and plug in a number. Okay? What do you do when you see this and this? What is the biggest shortcut people would tell you in math as far as what it is that you're doing? You're switching the x's and the y. Let's add more to that, okay? Listen. Look. Whenever you have a function, and let me do an easy example. I'm talking about like x squared and square root of x. What's f of 2? 4. So what's the inverse of 4? 2. Now look. The input, this is huge. The input of the original is the same as what? The output of the inverse. This is huge. Okay? Where the output of the original is the same as the input of the inverse. That's huge. From the shortcut that I'm going to tell you and show you at the end. But you won't understand the shortcut unless you understand that. Okay? So here we go. If you forget the shortcut, this is what you have to do. You have to first find what is the inverse of x, then derive it, and then plug in 2 to get your answer. Let's do that really quick. We have y is equal to x plus 7 over x plus 3. This is algebra 2. We switch the x's and the y's, and then we find the y all by itself. Looking at this, I'm going to multiply on both sides this y plus 3. This is very similar to the problem that we just worked. I'm identifying all the islands. I look for the pluses and the minuses. And all I see is that this is one huge piece because of multiplication, and then I have 2 terms over there. How many y's do you see? 2. Therefore, we're going to distribute to GCF later. So that if I move the y over all the y's to the left, I get xy minus y. And I move everything else to the right, I would get this. And the part that people struggle to see is that GCF piece right here with the y. So that y, otherwise now known as the inverse of f of x, is 7 minus 3 over x minus 1. This is a lot of work. And all we did was get the inverse function. Now we have to derive this. So we're going to do low d high minus high d low all over low squared. This is the derivative of the inverse function of f of x. Okay, we just found this. Now we're going to plug in 2. We're going to plug in 2 everywhere where we see, the input. And let's see what we get. Okay, so we have 2 minus 1. That's 1 times negative 3, negative 3. 7 minus 6 is 1. So we're going to be subtracting 1. And it's all over what? Come on, guys. Let's put the 2 in. It's all over what? 1. So what's my answer? Negative 4. That's a lot of work. And that right there is on the multiple choice section of the AP exam, and you should take less than 2 minutes for that problem. Okay, let me show you the shortcut. This is the shortcut, one of the big pieces from the silent ed puzzle. Okay? Here we go. The shortcut is this. Any time that I'm wanting to find the derivative of the inverse function, which is identified as this is the equation that you'll use. It's 1 over f prime of this. This will equal the derivative of the inverse function evaluated specifically at an a constant value. Now you look at that and you're like, what the heck is going on? Let me talk you through this, okay? This right here is what people struggle with. And if you could get that, I mean, the rest is cake. This is an inverse function. And it is going to yield an output of the inverse. You with me? So the output of the inverse, watch what we're going to do as far as this original function is concerned over here. F of x is equal to x plus 7 over x plus 3. And what we're trying to find right now is we're trying to find the inverse at 2. Let me show you the piece that I'm talking about. We're trying to find this. We're trying to find on the inverse function, what's the derivative of this inverse function evaluated at 2? So we would say 1 over f prime of the inverse at 2. Okay, here we go. I did this in blue for a reason, because a is 2. And the way you read what's in blue right here is the input of the inverse is equivalent to what? The output, bam, right there, of the original. So 2 is the output of the original. You with me? What would x be? You have to do a little bit of math. And these are the hardest ones that you'll have to show the most math, even with the shortcut. But it's a lot faster on all the other types of problems that you're going to see that are not rational functions. So you'd have like 2x plus 6 because you distributed. Get x alone on the left side, it's 1. That's easy math that you could just fly through, right? So x is 1. That means this right here becomes the following. 1 over f prime at 1. My goal was that this, which yields an output on the inverse, came from the input of the original. So that's why you put 1 right here. So what do I do now? Just take the derivative of the original, plug in 1, and take the reciprocal there at the end and you're done. Okay? So if you looked at the original, it'd be low d high minus high d low all over low squared. And what we would do is we would plug in this 1 that we got as far as that backward interpretation. And if I put 1, 1, and 1, I would get 1 plus 3 is 4, then minus 8, and then over what? Plug in 1 right here, what would I get? 16. You with me? So 4 minus 8 is negative 4. Over 16 is negative 1/4. But look, negative 1/4 is all of this. That we're going to take the reciprocal because it's 1 over that. And that's how you get negative 4. It feels like the shortcut wasn't all that much shorter, but the reason why that feels that way is because of the way the function that was given to us was a rational function with multiple x's. All these other functions that are going to be like polynomials and linear in a respect or quadratic, they're going going to be a lot easier to solve in this respect. Okay? So you don't have to go all the way of finding the inverse function because it's way too much work. And we'll do more example problems from supplemental homework in the couple of days to come. Any questions on this?